Okay, three coplanar forces of magnitude 20, 100 and F newtons act at a point. Well, there's our point. There's our F newtons, there's our 20 and there's our 100. Directions on the forces are shown in the diagram. Given the three forces are in equilibrium, find F and alpha. Equilibrium means it's not moving. It means there's no acceleration. Okay, so everything's balanced out. That means you can resolve in any direction you like and the resultant force is zero. So we could resolve horizontally like that. Okay, so F has a component going that way. The 100 newtons has a component going the opposite way, and the 20 newton has a component going the opposite way. But if you resolve in this direction, the resultant force in that direction will be zero. Also, if you resolve down, the resultant force down will be zero, or up, resultant force up will be zero. Whatever direction you like. We could resolve in this direction, the direction of the F force. Well, the direction in the F in that direction will be zero. It doesn't matter. So what we're going to do, we're going to resolve in two directions to collect equations, and each time we do it, we're going to get two unknowns. We're going to get an alpha, which is unknown, and we're going to get an F, which is unknown. Now you could, if you resolved in the direction of F, if you resolved in the direction 90 degrees to F, then F wouldn't be involved. But be very careful here. Okay, look, there's a 90 degree angle there because it says so. Now this looks like 90, but how do you know it's 90? Okay, you can't assume it's 90, can you? Okay, so be aware of that. Okay, let's assume that the 20 newtons force is not 90 to the F. Right, we're going to resolve horizontally to the right. Okay, so the total resultant force to the right is zero, or we can say the total forces to the right equal the total forces to the left. That's what we're going to do. So we've got three forces. So F is definitely going to the right, has a component going to the right. The 20 newtons has a component going to the left, and the 100 newtons has a component going to the left. Okay, well, let's do the F first. Right, now what's the component to the right? Well, that angle there is alpha. Therefore, if we resolve it in this direction, it's F cos alpha. Okay, I explained it in the last question. So it does have a component in that direction, but it also has a component 90 degrees to it in this direction. Okay, so in this direction it's F cos that angle, but in that direction it's F sine that angle. Or if you want, you can also say it's F cos this angle. Well, that angle is going to be 90 minus alpha. So you could argue, if you resolve it in that direction, it's F times cos, in brackets, 90 minus alpha, which is a bit messy. It's better to call that resolved direction as F sine alpha. Okay, so anyway, back to resolving to the right. So that's, in this direction, that's F cos alpha. Now what about the 20 newtons? Well, let's say that's going to the left, so let's put an equal sign. So forces to the right are going to go this side of the equal sign. Forces to the left are going to be that side of the equal sign, and they all balance out. So 20 newtons, well, that's not going exactly opposite. We need to resolve it. Okay, now what's that angle? That angle is 40. So in this direction, it's going 20 cos 40. Right, now, okay, that 20 newtons has a component going up, and that will be 20 sine 40. Or it will be 20 cos this angle. 20, what's 90 minus 40? 50. So that would be 20 cos 50 or 20 sine 40. I usually go with using the angles were given. Okay, so if it's 90 degrees to the direction, then it's sine. If it's in the direction, it's cos. So if you, incidentally, if you want to resolve that 20 newtons in this direction, it will be minus 20 sine 40. Anyway, let's carry on. What about the 100 newtons? Well, 100 newtons has got a component that way. So it's either going to be 100 cos this angle. Well, that angle is 90 minus 20, it's 70. So it's going to be 100 cos 70, but I prefer to use the 20. So rather than say 100 cos 70, I prefer to say 100 sine 20. So plus 100 sine 20. Okay, so working out on the calculator, 20 cos 40 times 100 sine 20, we get 49.5229. So we have an equation with two unknowns. Right, now let's resolve either up or down, or let's resolve up. Because f is more going up, let's resolve up. We could have resolved down, then we'd end up with a negative f. So resolve up the dotted line. So f is definitely going up. Now we need to resolve that going up. We've already resolved it along this dotted line. Well, 90 degrees to it will be the same, but sine. So that's going to be f sine alpha. Now the 20 newtons, that's also going in the direction of up rather than down, so that's going to be a positive. So we got plus 20. Well, 20 cos 40 is the component in this direction, so this direction will be 20 sine 40. Alright, that's all. Those are all the forces going up. Right, what about the 100 newtons? Well, the 100 newtons is definitely going down, so we're going to have that on the other side of the equal sign. So it's going to be 100 cos 20. Okay, if you're getting confused between sines and cos, don't worry, you're not alone, everyone does. But you must be clear on it, okay? Okay, we've got our equation finishing off. Okay, work out 20 sine 40, 100 cos 20, and then take the 20 sine 40 over. You end up with f sine alpha is 81.1135. Right, the smart way of working out f and alpha is to work them out independently. Okay, and you'll do more of this in pure maths, where you'll get this sort of situation, and this is definitely the best way of doing it. We're going to square the left hand side and then add them, and I'm going to square the right hand side and add them, and you'll see why. Okay, you're thinking, well, why have we done that? Okay, well, if you factorise this, you'll see, and take f squared out, you'll see you'll end up with cos squared alpha plus sine squared alpha, which is 1. Okay, so we end up with f squared in brackets cos squared alpha plus sine squared alpha, which is 1. Okay, so really we got f squared equals 9031.917507. Therefore, f equals square root of 9031.917507, which is 95.04. Okay, so we found f independently of alpha, and now we're going to find alpha independently of f. And we could just sub f as 95.04 into one of these, but it's much better practice to work them out independently if you can. Okay, now to work out alpha independently of f, what we're going to do now is divide one by the other. We're going to divide this one by that one. So we'll end up with sine alpha over cos alpha, which is tan alpha. Okay, so we got f sine alpha over f cos alpha equals 81.1135 over 49.5529. And you can see the f's cancel out, and we're left with sine alpha over cos alpha, which is tan alpha. So tan alpha equals, so tan alpha is 1.6379, so alpha is the inverse tan of 1.6379, which works out to 95.04. And that is the best way of calculating alpha and f when you've got an equation like that, and it happens a lot in A-level maths, and it's really the best way of doing it. Okay, so f is the square root of that squared plus that squared, simple as that. And alpha is the inverse tan of 81.1135 over 49.5229. You'll do it so many times, it will become second nature.